Hey everyone, and welcome back to AI Podcast. We are diving into something pretty groundbreaking today, a new breed of large language models called diffusion-based LLMs.
Mm,
You know how we've been hearing so much about LLMs like GPT-3?
right.
Well, this new approach is turning heads because it tackles some of their biggest limitations.
Yeah.
And get this, there's a company called Inception that's already making waves with this tech.
Interesting.
They've even launched a product called Mercury, which is turning out to be way faster and cheaper to run.
Wow.
Intrigued? I thought so.
Definitely.
Let's unpack this together.
Sounds good.
So what's fascinating here is how these diffusion-based models work. They're fundamentally different from the usual autoregressive models like GPT-3, which
Yeah.
kind of write a story one word at a time,
Yeah.
predicting the next word based on what came before.
Exactly.
Right, like a super-powered autocomplete.
Yeah.
But you're saying that approach has some drawbacks.
Exactly. Imagine trying to write a novel where each sentence only makes sense in relation to the one before it. You'd miss out on the intricate plot twists and character development that make a story captivating.
Right.
These autoregressive models can be computationally expensive and struggle with that bigger picture,
Yeah.
that bidirectional context.
Okay, so how do diffusion models change the game?
Think of it like developing a photograph.
Okay.
You start with a blurry image, almost like a noise field,
Yeah.
and then gradually refine it until a clear picture emerges.
Okay.
Diffusion models work similarly. Instead of predicting the next word, they start with a sequence of masked tokens.
Okay.
Think of it like a sentence full of blanks.
Yeah.
Then they iteratively remove the masks, refining the text with each step.
So it's like a sculptor chipping away at a block of marble, slowly revealing the masterpiece hidden within.
That's a great analogy. And what's brilliant is that this process allows the model to consider the entire sequence, not just what came before.
Yeah.
It's like being able to read a whole paragraph before finalizing that first sentence.
No, that's what I call context. But hold on. Why is this look at the whole picture thing such a big deal?
It unlocks some incredible advantages.
Okay.
First off, diffusion models excel at understanding bidirectional context.
Okay.
They can capture relationships between words that are far apart, leading to more coherent and natural-sounding text.
So they're not just stringing words together, they're grasping the meaning and weaving a tapestry of language.
Precisely. And this leads to another key advantage: enhanced reasoning capabilities.
Okay.
Because they can consider the entire sequence, they can adjust earlier parts of the text based on what comes later. Imagine you're writing a mystery novel. A diffusion model could cleverly plant clues early on that perfectly align with the big reveal at the end.
Right.
In a way, traditional models just couldn't.
Wow, that's impressive. It's like they're thinking ahead, plotting and scheming like a master detective. Any other perks to this diffusion magic?
There's more. Some diffusion-based approaches allow for parallel token generation. This means they can generate multiple tokens at the same time, instead of one by one, making them significantly faster than traditional models.
So they're not just smarter, they're speed demons too. All right, I'm officially intrigued, but let's move from theory to practice.
Okay.
Tell me more about Inception and how they're putting this cutting-edge technology to work.
Inception is a fascinating company founded by Stanford professor Stefano Ehrman.
Okay.
They're on a mission to revolutionize AI using these diffusion models.
Right.
And they're walking the walk with their flagship product, Mercury.
Mercury, huh? Sounds intriguing. What's so special about it?
Mercury is making headlines because it's the first commercially available large-scale diffusion-based LLM, or
Sweet.
DLLM for short.
Right.
What's really cool is that it uses a coarse-to-fine approach.
Okay.
Think of it like starting with a rough sketch and then refining it with finer and finer details until you have a masterpiece.
Right.
This makes it blazingly fast compared to traditional models.
Okay, spill the beans.
Yeah.
How much faster are we talking?
Hold on to your hats. We're talking up to 10 times faster. And here's the kicker. It's also much cheaper to run.
Wait, hold on, cheaper and faster. That sounds almost too good to be true.
Yeah, it is pretty remarkable.
What's the catch?
There's no catch. This is one of the most exciting aspects of Inception's work. They're tackling the major roadblocks in AI head-on.
Oh, okay.
Traditional LLMs need a ton of computing power, which means access is limited to those with deep pockets.
Right.
But Inception is changing the game.
So you're saying they're democratizing access to cutting-edge AI. That's huge. But how are they pulling it off?
One word: scalability. Diffusion models are inherently designed to scale more efficiently,
Okay.
meaning you can achieve incredible results with less computing power.
So it's not just about building bigger models, it's about building smarter, more efficient models. That's a game changer in itself.
Absolutely. And that efficiency directly translates to cost savings, making advanced AI accessible to a much wider range of users and applications.
Okay, I'm starting to see why Inception is making such a splash. But let's talk about the elephant in the room, that advanced reasoning we discussed earlier.
Right.
How is Inception actually delivering on that promise with Mercury?
It all comes down to the way diffusion models process information.
Yep.
That bidirectional iterative nature we talked about allows Mercury to achieve a level of understanding and nuance that was previously out of reach.
Hmm.
Think of it like a writer who can constantly revise and refine their work based on the entire story, ensuring every detail fits perfectly.
So we're talking about an AI that can grasp complex relationships and reason its way through intricate problems.
Exactly. And that opens up a whole universe of possibilities for real-world applications. Imagine the potential in fields like healthcare education and even creative industries.
Right.
Yeah.
But let's get down to the nitty-gritty. How is Inception actually using this technology to change the game in the real world? What are the concrete applications?
Let's start with healthcare. Imagine a doctor who's drowning in medical research, trying to keep up with the latest breakthroughs while also caring for patients.
Oh, yeah. That sounds overwhelming. I can barely keep up with my email inbox, let alone the latest advancements in gene therapy.
Exactly. But with a diffusion-based LLM like Mercury, that doctor could have an AI assistant that summarizes those dense research papers in seconds.
Okay.
It would highlight the key findings and even explain their relevance to the doctor's specific area of practice.
That's incredible. Doctors could spend less time reading and more time treating, and patients would benefit from the most up-to-date knowledge.
Precisely. And this is just scratching the surface of what's possible in healthcare. We could see AI-powered diagnostic tools that analyze medical images with incredible accuracy, helping to catch diseases earlier. Or personalized treatment plans generated by LLMs that take into account a patient's entire medical history, lifestyle, and genetic predispositions.
It sounds like we're on the verge of a healthcare revolution. It makes you wonder what else these diffusion-based LLMs could transform.
Well, how about education? Let's be honest, traditional classrooms often struggle to meet the needs of every student. Some students might grasp concepts quickly, while others need more time and support.
It's the classic one-size-fits-all dilemma, and we all know how frustrating that can be, whether you're the student or the teacher.
Exactly. But imagine AI tutors powered by diffusion-based LLMs that can personalize lessons in real time, adapting to each student's individual learning style and pace.
So if I'm struggling with a concept, the AI tutor would patiently explain it in different ways until I get it.
Right.
But if I'm flying through the material, it would challenge me with more advanced concepts.
That's the idea. These AI tutors could provide personalized feedback, answer questions in a way that makes sense to each individual student, and even design custom practice exercises to reinforce learning. It's like having a personal tutor available 24/7.
Wow, that could completely change the way we learn. Students would be more engaged, they'd learn at their own pace, and they'd get the individual attention they need to succeed.
And it wouldn't stop there. These diffusion-based LLMs could also help educators create more engaging and interactive learning materials, grade assignments more efficiently, and even identify students who might be at risk of falling behind so they can get the support they need.
It's mind-blowing to think about the possibilities. And I can't wait to see what the future holds for this transformative technology.
Me too. The possibilities are truly endless.
And to all our listeners out there, thank you for joining us on this adventure. We hope you've learned something new and that you're as excited about the future of AI as we are. Make sure to join us tomorrow evening for another deep dive into a brand new topic. We'll see you then.